Okay everybody, so we ended off with the last video being about the continent type 3 continent collisions on your convergent plate boundaries. So this is when, to recap, when those plates are moving toward each other, and in this case it's two continental plates. But this obviously didn't start off as that type of boundary. Before that we were looking at something like this, where the Indian plate was moving towards the Asian plate, consuming oceanic crust. So there was oceanic crust that was being subducted in that area, and you had this volcanic activity initially. But then as that carries on, you can imagine that this plate is sooner or later going to knock into this continental plate, and you're going to lose that entire oceanic plate beneath it. And that's what happens. That's what happened with India and Asia. So you had these two continental plates then colliding and creating massive collisional mountain belt structures. And that's what we see the Himalayas as, these large, extremely elevated mountainous regions. So starts off with the consumption of the oceanic lithosphere, oceanic crust, and that causes the continent collision from this to that. And if we continue, we can see another image here of it. So you have the Asian plate on this side and the Indian plate on this side, and they collided, forming these massive folding mountains above it. So you can see that it resulted in some thrust faults and normal faults, and we'll get into the details of faulting in future lessons. For now, you can just understand that these collisional areas, and this is again a picture of that area zoomed in, these collisional continent collisions create massive mountain ranges like the Himalayas. Here we see another picture. I just wanted to show you guys to clear that up. Here we see from Portrait of a Planet by Stephen Marshak. We have 71 million years ago, the Indian continent being there out there in the ocean, and then through the years it got moved and pushed up and consuming that oceanic crust until it reached the Asian plate, the Asian continent, and that collision created these massive mountains you see over here, and you can see it here again, those mountainous regions with that plate knocking into the Asian plate. So now that we've completed convergent boundaries, let's talk a bit about divergent boundaries. So divergent boundaries is the moving apart of plates. So we've spoken about the different processes where you get the plates moving together. Now we're talking about the processes where the plates are moving apart. So they're moving apart or rifting. Rifting really only refers to the continental rifting, but we'll get into that. So just understand that divergent means to move apart. So this rifting or moving apart causes what we know now as seafloor spreading. One of the fundamental ideas to make sense of continental drift is seafloor spreading and the information surrounding the mid-oceanic ridges. So some of the features we're talking about, one of them is the mid-oceanic ridge. We've spoken quite a bit about that. Then rift valleys and fissure volcanoes, and we can speak about that in a moment too. So here's the image of the mid-oceanic ridge, the MOR. It's the thinnest point of oceanic crust. This is where new crust, oceanic crust, is created. So the crust is actually made here with that hot material rising to the surface, cooling down, solidifying, and then in essence becoming oceanic crust. And then new material comes in again, hot asthenospheric material, cooling down, hardening, and spreading. So these arrows show you that from this central point, the oceanic crust is moving to either side. So it spreads apart from this area. And that is the divergence, right? The moving apart that we spoke about. So this is known as a MOR, or mid-oceanic ridge. So here we just see another image just to solidify that you guys understand. If we started at time 1 over here, time 1, we have plate A and B that are being spread apart by that mid-oceanic ridge with the new creation of oceanic crust. Then we can see now that original pieces of oceanic crust are now these pieces against the continental plates, and there are new oceanic materials being formed in the center, and that continues as such. So you have that movement of those two plates because of that mid-oceanic ridge growth. So the next divergent plate boundary is called a transform fault boundary or transform faults. Transform boundary between two plates that are sliding past each other, and this also causes a lot of earthquakes, more frequent earthquakes than any other type of fault, is this transform fault boundary, and we're going to speak about that. So this is what that looks like. You have two plates that are not being subducted, not pushing up against each other, not departing each other, but rather just sliding past each other like this, and it's called a transform boundary or a transform fault. You can see there the sideward stepping of the MOR, and we're going to see a picture of that now in a moment. So this is one of the most active transform fault boundaries in the world, and it is in the United States. It's the boundary between the North American plate and the Pacific plate. So relative to each other, the North American plate is moving downward and the Pacific plate is moving upward. So they're moving, sliding past each other, and you can see that this is happening at that boundary over there, and that causes a lot of earthquakes in that San Andreas area. And Los Angeles is quite well known for the earthquakes that occur there. I'm sure some of you have seen the movie with The Rock in it, and they show how badly these types of earthquakes can really affect the world at its worst. But again, that is a science fiction movie, so don't believe everything you see. Anyway, continuing. So we can see some transform faults there and over there and another one over there, but the main transform fault is this line over here running through in San Andreas, and that causes devastation in that area. This is what it looks like. This is the actual fault where those pieces, those two plates, are moving past each other. But what's important to note is that these plates are not just moving past each other, they're not just sliding past, they're also subducting beneath one over the other. So you have not only a transform fault but also a subduction zone. So there's two types of movement happening in that plate, and that causes devastating earthquakes. So here we see again transform fault that we looked at earlier, the picture over there. This is easier seen when you have a mid-oceanic ridge that's being split up like this, because then you can see, okay, there's the one part of the oceanic ridge, and then you have the movement and the transformation, the transform fault in between those two pieces, and you can see that now the MOR continues over there. So it might seem like they were separated, but they actually were connected at once upon a time, and now they're separated by that movement of the transform fault. So here again is a better picture showing you what's happening there. We have the North American plate moving this way and downward, and the Pacific plate moving upward and to the right from this perspective, and that causes a lot of earthquakes in that area. This is that ridge, that fault being shown here down the middle. So again, just another image showing you that in a different perspective. If you didn't understand how that MOR would look from above, is over here. So you have the MOR in the center, and it's been transformed over there, and plate A and B is now shifted. So just a recap on some of the boundaries we talked about. This is our subducting boundary, and it is at the convergence. So convergent meaning coming together, and in this case we have oceanic and continental, so we have the subduction going on and the oceanic plates being subducted below the continental plate. So you might be asking what causes these movements, and we spoke a bit about it, but it's the hot magma moving around below the crust of the earth. So in the mantle, that hot material, those hot plastic-like rocks move around in the earth, below the earth's surface, and that convection from the heat that they have associated with them creates these convection currents beneath the plates. So it's almost as if there's a current below the plate that moves the plate along, and here we can see that. So we have the hot material rising to the top. Here's the mid-oceanic ridge in the center, and that hot material then spreads out, and as it cools down and is pulled down with some subducting plates, we have that circulation of that material. So hot material rises, cools down in this process, and then sinks down and heats up again, and this continues constantly helping these different plates to move across the Earth's surface. But this again happens over millennia. It's not something that happens very quickly. It's a slow process. Sometimes you can have small jolts of speed with earthquakes and things like that when the pressure is released, but otherwise it's a very slow process. But it does happen constantly over time. Here we have again another show of that picture from the Indian plate moving, being subducted, and then creating a continent collision, just to summarize. And here we have a show of how oceanic crust is being created in this point at the mid-oceanic ridge, being pushed away from each other, pushed apart, and that causes this continent to move this way, continental plate, and causes the subduction of this oceanic plate over here, the older oceanic plate. So this is a good example of how this material is pushed from the MOR. Okay, here we see a nice world map showing you how the movement of the African plate and the Indian plate and the Arab plate northward is causing this, or has caused rather, this massive belt of mountains ranging from the Himalayas to the Alpine mountains in Europe. And you can imagine that over a couple of hundreds and thousands of years, that these plates will then eventually cause the Mediterranean Ocean to not exist. And then lastly, here's an example of all the different plate boundaries across the world. We see here in the Mediterranean areas subduction of that African plate beneath the European plate over there. Then we have the Himalayan mountain building event, where we have the Indian and the Asian plates converging. Then here we see the rifting of the continent of Africa through Ethiopia. So there's a massive continental rift occurring in Africa, and one day that Ethiopian, the Horn of Africa itself actually, will come apart from Africa, and just like India did in the past. Then here on this end we see again another subduction zone between the oceanic plate and the Pacific. It's being subducted beneath the South American plate, creating those Andes mountains. Then what I want you guys to do in your books is to write down, follow this image and write down numbers 1 to 5, and I want you to label each of them. I'll give you the first one just to give that answer away. This is the MOR, the mid-oceanic ridge. So you write down 1 and you say mid-oceanic ridge, and 2 and you give the answer. So you have to say what is happening at each of these. Your notes in your textbooks and your summaries and these videos will assist you to do that. Excellent, thank you very much, and on to the next one.